Hello, we have started this lesson, but here's what we're doing today. We're going to take the factoring that we did a couple classes ago, and we're going to apply it and solve equations with it. So this first example asks us to find the roots and verify your solutions. So in the yellow highlighting, we have 4a squared minus 25, which is a difference of squares. We factor that to give us 2a plus 5, 2a minus 5, and it's equal to 0. This is an equation, so we need to write both sides of the equation on every step. And then, understanding that if we have the green blob times the blue blob, and that's equal to 0, if we're multiplying any two numbers and we get 0, we know that at least one of those numbers is 0. So we can set both of those things equal to 0. That is to say that we know that 2a plus 5 is equal to 0, or 2a minus 5 is equal to 0. And in both cases, what we're going to do is we're going to use those little equations and we're going to solve for a. So the left one first, 2a would equal negative 5, and a would equal negative 5 halves. Likewise with the other one, 2a equals 5, a equals 5 over 2. So our two answers, or two values of a that solve this equation, are negative 5 over 2 and positive 5 over 2. Now, that's the part of the question. The first part of the question says find the roots. That's the finding the roots part. After finding the roots, it asks us to verify the solutions. So that's this next part, the check. We take a look at the original question, 4a squared minus 25 equals 0. And we're going to start with negative 5 halves. We're going to plug it in every place we see an a on the left side of the equation. So when we do that, we get here. Negative 5 halves squared is 25 over 4, and then we'll go minus 25. Then we'll simplify. 4 times 25 is 100, but when we divide it by 4, we get 25. So 25, take away 25, is 0. Yay! So that tells us that negative 5 halves is a root or an answer to the equation because it's equal to the right side. So we should say left side equals right side. Now we need to do the exact same thing with the other root, which is positive 5 over 2. So the left side is 4 times positive 5 over 2 squared minus 25. Simplifying, again, when we square it, we get the same thing, 25 over 4. And that's also equal to 25. So subtracting 25 from itself gives us 0. So therefore, the left side is equal to the right side. And our two answers to this quadratic equation are 5 over 2 and negative 5 over 2. And it's not a bad idea, once you've done the check, to make a little statement of what the answer is. So the letter we used in this question, I think, was A. So just therefore, a equals negative 5 over 2 and positive 5 over 2. And that's kind of our concluding statement. And the purpose of the check or the verification is to make sure that we did it right. If the left side was not equal to the right side, it would tell us that something we did was wrong and we should look back and fix it. So the check is more for our benefit than anything else, but we should still show it, especially if we want full marks on a quiz. By the way, there is a quiz on this next class. Next question. Find the roots, verify your solutions. So again, we're going to have to check it. This is a so-called difficult trinomial because you can't factor out a single common factor out of all three terms, and there's a number other than 1 in front of the squared term. So we're looking for two numbers that multiply to negative 60, getting that by multiplying 6 and negative 10 together, and we're looking for two numbers that add to negative 17. This is a tricky one. Sorry. So two numbers that multiply to negative 60, and add to negative 17. Negative 20 and 3. That's correct. Negative 20 and 3. So it's going to be 6b squared. Probably going to put the negative 20b here, and I'm going to put the plus 3b here, minus 10 equals 0. What we're going to need to do is we're going to need to factor the first two terms and the last two terms by grouping. And of course, when we do that, we hope to get the exact same thing in both sets of brackets. So what can we factor out of the first two terms that's common to both two terms? The biggest thing. To be or not to be? We can take 2b out, and we're left with what? What are we left with when we take out a common factor of 2b from those first two terms? 3b minus 10. Now this is a unique situation because I have 3b minus 10 right here, but I also have exactly 3b minus 10 over here, which makes me look at the 3b minus 10 on the line above and ask myself, is there something I can take out of 3b minus 10 to reduce that? And the answer is no. So if there's a situation like this, I can take out 1. I can take out 1. So I take out plus 1, and I'm left with 3b minus 10 over here, and that's okay. That's okay. Just means I can't take out anything. So I take out 1. Because you can always divide stuff by 1. You're not changing something by dividing it by 1, but you can take out 1. 1's always a common factor. So then I'm going to factor by grouping, which is take what's common to both those blobs, the 3b minus 10, and then I have 2b plus 1 left over, and there we go. There is the factoring of that quadratic equation. So now I've got 3b minus 10 and 2b plus 1 multiplied together to give me 0. So that means that we got to set them both equal to 0 and solve for b. So 3b minus 10 equals 0. 2b plus 1 equals 0. So we got to solve for b in both cases. 3b is equal to 10. B is equal to, we got to be careful here. I'm not going to say who, but someone gave me an answer earlier and gave it to me as a decimal. We can't use a decimal answer because then if we try and check it, it's going to be thrown off. We want to use exact values, that is reduced fractions. So it's just 10 over 3, and that's good enough. So b is 10 thirds. That's one of our answers. We don't have to write it as 3 1/3. 10 thirds is perfectly fine. We'll move on to this one. Excuse me. 2b is equal to negative 1. And by dividing both sides by 2, b is equal to negative 1/2. So we have two solutions. Two solutions that we must verify. One of them might be, well, I mean, when it comes to quadratic equations like this, as long as we did the math right, they'll both verify every time. There are certain equations that you might study later in math that some of them, even if you find them, some of them aren't going to work. But these ones will always work so long as you do the math right. So let's see if we did the math right. Let's verify it by plugging it into the original equation. So we're going to do the check. Again, the original equation, 6b squared minus 17b minus 10 equals 0. So this is what we're using to check those two answers. Doesn't matter which one we start with. makes the most sense to me to start with the first one, but it really doesn't matter. So we're going to check 10/3 first, and this is why it's important to keep that as a fraction, because we're going to be working with it. It's going to be a little ugly, I'll admit. So 6b squared, so that's 10/3 squared, minus 17 times 10/3, minus 10. So an ability to manipulate fractions is important here. We are going to square 10/3, and that's going to give us 100/9. And when we multiply 17 by 10/3, we're going to get 170/3. I see the writing on the wall here that I'm dealing with thirds, and it's kind of unpleasant, but I'm going to make sure that I'm dealing with thirds everywhere. So 10 is what divided by 3? If I write it as an equivalent fraction, 10 is what over 3? 30. So I'm going to write 10 as 30/3. Now that I got common denominator on everything, or most things, it's going to make this a little bit easier. The first piece, 6 times 100/9, is going to be 600/9, and we'll deal with that soon. The last two pieces can be combined. They're both negative, so they can be combined together to give us 200/3. They could both be combined to give us 200/3. And then dealing with these two fractions, we need a common denominator. So it doesn't matter which way we go. I can multiply this by 3 and this by 3. So 9's our common denominator. That's no problem. And if I do that, I've got 600/9 minus 600/9, which is equal to 0, which is equal to the right side, which tells me that 10/3 is a solution to this quadratic equation. There's the payoff. We know that 10/3 works. Now what we're going to do is we're going to substitute in minus 1/2. I think minus 1/2 was our other solution. It was. So check minus 1/2. So left side, same thing. 6 times minus 1/2 squared minus 17 times minus 1/2, then minus 10. And we have to work with this. Number's going to be a little bit easier to deal with. So we're squaring negative 1/2. That gives us a quarter. If we're multiplying negative 17 by negative 1/2, we're going to get positive 17/2. And if I see the writing on the wall and we have over 2, then I should write 10 as something over 2. 10 would be what divided by 2? 20. The first fraction becomes 6/4. Then I have these guys. What I could do is I can make these second and third fractions. I can write these over 4 if I want to. Maybe I will. So this would be, if I double both the top and bottom, 34/4. And if I double the top and bottom, I get 40/4. And that gives me, what does that give me when I combine those fractions together? 0! So therefore, left side is equal to the right side. So therefore, what was the letter in this question? B. B equals 10/3 and negative 1/2. Solved and verified. Solved and verified. I think we have one more question, and that's practice time. The roots of an equation are 5 and negative 1. How can you find an equation with those roots? This is a neat question. It's a neat question because it's completely different than the other questions we've done. The first two questions we've done, we've been given an equation and we've been asked to factor it and solve for the letter. Here we are being given the values. We're given the values and it says, what's an equation that has those answers? So how do we do it? How do we do it? It's important for us to remember what these represent. Look, thinking back to last class, 5 and -1 represent what of the graph if we graphed it? What do they represent? The x-intercepts. That's exactly it. So what we can do, and we can just think about this for a second here, okay? I'm going to draw a graph here. Nothing fancy. So I'm just going to draw a graph. I've got 5 and -1 as my x-intercepts. So maybe this is 5, and maybe this is -1. Now, we're literally given no other information. So really, we could come up with an equation that opens up, opens down, like the function that's represented by the equation. It could be pointing up, it could be pointing down, it could be skinny, it could be fat, it could be almost anything. The question is, what do we want to do? Well, here's the thing. Go ahead. Here's the thing. Yesterday we were given a graph, and I said, we're going to take the graph and we're going to find out what the equation is. And how we did that is we looked at an equation like this. I said it was y equals a times x minus r or something and an x minus s, where r and s were the x-intercepts. So if we use that same idea, doesn't matter which one's which, I can call this r, I can call this s. So y equals x minus -1, which is plus 1. If I simplify it, x minus 5. Now for this to be an equation, it must be equal to 0. And then what I have to do is I have to figure out what I want to make a equal to. But you know, the cool thing about this question is it doesn't matter what a is. It really doesn't. We can make a anything we want. In other words, I can leave it just as this and let a be 1. I could put a 2 here. I could put a -5 here. I could put a 6/3 here, 7/8, whatever. It doesn't matter what I put here, as long as I don't put a 0. Zeros are bad, because 0 would make the whole thing gone. So really, I'll put a 2 here, but oops, that's not what I want to do. I'll put a 2 here, but that a value doesn't matter. So this right here is a quadratic equation that has the roots 5 and -1. The a value is inconsequential. So it's just x plus 1, x minus 5. Now, what if the question said, because it doesn't say this. It doesn't say this, but what if it said the equation has to be in standard form? Something x squared plus something x plus a number. How would we deal with that? What if it wanted it in standard form? Here's what we would do. So this is fine, but if we want to write in standard form, this is what we have to do. We have to multiply x plus 1. Well, you know what first thing I'm going to do is I'm going to multiply 2 by both of those things. If I multiply 2 by both of those things, I'm going to get 2x plus 2 inside the bracket, and the 2's used up. I don't have to, the 2 is not used anywhere else. So now I've got 2x plus 2 times x minus 5. And then I just have to multiply both of those brackets together. And when I'm multiplying two binomials together, remember, I go from the first term of the first to the first term of the second, first term of the first, second term of the second, second term in first, and second term in second. So initially, anyway, there should be 4 terms when you expand this. 2x times x is 2x squared. 2x times negative 5 is negative 10x. 2 times x is positive 2x. 2 times negative 5 is negative 10. And then what we could do is simplify the middle 2 terms, and that would give us negative 8x in the middle. And this right here would be our quadratic equation in standard form with the roots 5 and negative 1. Okay? So if you have to write in standard form, you just expand it and simplify it, and you're off to the races. Your homework is on pages 405 to 407, numbers 1 to 15, and there is a quiz tomorrow.